Today's lesson is on a continuation of slope, looking at slope in a different way. We're going to begin by looking at slope as a rate of change. In the second half of this lesson, we're going to be looking at slope as first differences. The main part of this course is learning about linear relations. A linear relation is a relationship between two variables that, when graphed, would create a straight line. So then naturally, a nonlinear relation is a relationship between two variables that, when graphed, would not create a straight line. In the grade 9 course, we only study linear relations, straight lines. In grade 10, you learn about nonlinear relations. A line segment is 2 points that are connected by a straight line. We call 2 points connected by a straight line a line segment. And remember that the steepness of a line is called slope. We can find the slope of straight lines. Here's an example. Given one endpoint E and the slope of the line segment, find the coordinates of the other possible endpoint F. I'm going to first draw a Cartesian plane. Here is my Cartesian plane. I drew the second quadrant much larger, anticipating that I'm going to be working in that quadrant. I'm going to first plot my point E, which is at -9, 6, which is about here. And I'm going to label it E. Then I'm going to use my slope to find a possible other point for F. My slope is -4. Now remember that all whole numbers have an invisible denominator of 1. So this is technically over denominator 1. And when we are working with slope, it's easier for us to have it in fraction form so that we have a rise and a run. Now, in this example, our rise is -4, so we're actually falling 4, and we're running 1. I'm going to use my slope now to find a possible point of F. I'm going to fall 4, starting at E. 1, 2, 3, 4. And I'm going to run 1, 1. Now I can connect my 2 points to create a line segment. The possible endpoint F has the coordinates -8, 2. An x-intercept is a point where the line segment intercepts with the x-axis. So along the x-axis, y is always equal to 0. And when your line segment meets the x-axis, we call that an x-intercept. And a y-intercept is when your line meets the y-axis. So here's your y-axis, where your line segment meets the y-axis. we call that a y-intercept. It's intercepting with the y-axis. Let's look at some word problems. For a road to have a grade of 3.7%, how far does it rise over a run of 400 meters? Now it tells you that the grade of a road is the slope. So the grade of 3.7%, this is my slope. How far does it rise? We're trying to find rise. And it tells us our run. So I'm going to begin with my slope formula. So I'm given my slope, and because my slope is presented to me in percent form, I'm going to actually change it into decimal form. Whenever you're given a percent in a question, before you use that value in your calculations, ensure that it's in decimal form. To convert from percent to decimal form, I'm going to take my percent and I'm going to divide it by 100. So 3.7% is equal to 0.037. Now on my next line, I'm going to substitute all the given values, and I'm going to use my decimal form to replace slope. We're trying to find rise, so I'm going to leave it as rise, and my run is 400. So I'm trying to isolate rise. I'm going to move my 400 over to the other side, and it's going to become its opposite operation. On the right, it's division, so on the left, it will become multiplication. Therefore, the rise of the road is 14.8 meters. Example 2. A daredevil walks along a tightrope between the tops of two buildings that are 20 meters apart. One building is 28 meters tall. The other building is 34 meters tall. What is the slope of the tightrope? Let's draw this out. Here are my two buildings. And there's a tightrope that is between the tops of the two buildings. So I'm going to connect a tightrope to the two roofs of the buildings. And the buildings are 20 meters apart. One building is 28 meters tall, and the other is 34 meters tall. So the shorter one is the 28 meters tall, and the taller one is 34 meters. What is the slope of the tightrope? So I need a rise and I need a run in order for me to find the slope. I already know what my run is. If the distance between the bottoms of the buildings are 20 meters, I would assume that the distance between the tops of the buildings are also 20 meters. So this is my run, 20. Now I need to find my rise. My rise is going to be this section here. The rise section also happens to be the difference between the taller and the shorter building. So what I can do is I can subtract 28 from 34. So I know that starting from the top of the shorter building to the top of the taller building is a 6-meter difference, which is my rise. Now we can find our slope using our slope formula, rise over run. My rise is 6 and my run is 20. And reducing that to lowest terms, 3 over 10. Therefore, the slope of the tightrope is 3 over 10. Remember to leave your slope in fraction form unless specified otherwise. And remember that slope does not have units. Next example. Calculate the pitch of the roof below. It tells us that the pitch of the roof is the slope of the roof. So I need a rise and I need a run. To make it easier for me to find my rise and run, I'm going to divide this roof into 2. Each side of this roof has the same slope. So I can just find the slope of one side of the roof, and that'll be the slope of the other side of the roof as well. So since I divided the roof into 2, that means that this half of my run is 15, and this would also be another 15. And I already have my rise. My rise is 12. So redrawing half of this roof so that it's easier for us to see. My run is 15, my rise is 12, and I'm trying to find my slope. Slope is equal to rise over run, which is equal to 12 over 15, which is equal to 4 over 5. Therefore, the pitch of the roof is 4 over 5. So that was a review of slope, finding slope in words. So now let's get into rate of change. The rate of change is a change in one quantity relative to the change in another. Just like when we were finding a unit rate, we're taking two quantities that have different units and dividing them by each other, and that's a unit rate. Here's an example. Sarah is on the soccer team and runs every morning before school. Her Fitbit activity tracker recorded the following details of her run. So here is a table of values. The left-hand column are your x values, your independent variable, and the right column is the y values, or your dependent variable. In part A, it's asking us to graph Sarah's distance as it relates to time. I'm going to begin by drawing my axes and labeling my axes. So my x is time, and I'm going to include units. And my y is distance in kilometers. I'm labeling my x and y axes according to what the table of values is labeled as. I'm also going to include an appropriate scale. So my origin is always 0. And I'm going to increase by 5s. And my y, I'm going to increase by 1s. And now I need to plot my points. And my points are actually in the table of values, but just presented in a different way. So the information provided to us in the table of values, we must convert to points on a graph. So reading from left to right, the first row is 0, 0. Your x value is 0 and your y value is 0. These are actually coordinates, 0, 0. And together create a point that we can plot on the graph. Next, we have coordinates 5 and 1, which would be 0.51. Next, 10, 2, 10, 2. Next, 15, 3, 15, 3. And finally, 24, 24. Next, we're going to take these 5 points and plot them. 0, 0 is at the origin. 5, 1, 10, 2, 15, 3, and 24. And then I'm going to connect my points using a ruler to ensure a straight line. I'm going to include an arrow at the end of my line segment to indicate that this linear relation would continue in that direction if extended. Now it's asking us to calculate the slope of the line. Now, to calculate the slope of the line, we can use any 2 points. Because this is a straight line, the slope would be the same between these 2 points and these 2 points and these 2 points and these 2 points. It doesn't actually matter which 2 points you use because, like I said, this is a straight line. So the slope is continuous from one end of the line segment to the other. To find slope, I can pick 2 points and then calculate the change in y over change in x, or I can use rise over run. It doesn't really matter. Using rise over run, I'm going to pick points 5, 1 and 10, 2. The rise between these 2 points is just 1. Look at how I've numbered my scale for my y-axis. 2 grid lines is 1 unit. So the rise between these 2 points is just 1, not 2. It's 2 grid lines, but 1 value, or 1 kilometer. That's the unit for this example. Also pay attention to how the x-axis is numbered. 2 grid lines represents 5 minutes. So my run here is 5. So we're rising 1 and we're running to the right 5. Now it's asking us to explain what our slope means. Well, we're rising 1 kilometer and we are running 5 minutes. This means that Sarah runs 1 kilometer every 5 minutes. So if we wanted to find the rate of change, we found the slope, but to find the rate of change, what we could do is we can actually just convert this slope into decimal form and include a unit rate, or both units that are part of this question, so minutes and kilometers. So 1 divided by 5 is 0.2. Sarah runs at a speed of 0.2, and now including my unit rate, which is both of the units in the question, my numerator and denominator units together, kilometers per minute. So the slope actually describes the rate of change. Another way of displaying the slope information is in rate of change form, which is just slope in decimal form with units. Page 4. You got the new iPhone and are deciding on which cell phone provider and data plan is best suited for your usage. You stumble upon a graph that shows you the cost per gigabyte of data for Freedom, Fido, and Bell. Calculate the slope of each line. So let's practice using the change in y over change in x slope formula in this question. Let's begin with Bell. I'm going to pick 2 points on the line segment. Bell is the yellow line segment. I'm going to begin by picking 2 points. I'm going to pick this one, 260. And I'm going to pick this one, 8, 120. Again, it doesn't matter which 2 points you pick because it's a straight line. The slope is going to be the same no matter where you're determining the slope. Just ensure that you're picking points that are easy to read. So follow the grid lines. This is my x1, y1, my x2, y2. So the slope for Bell is equal to y2 minus y1 divided by x2 minus x1. 120 subtract 60 divided by 8 subtract 2. 60 divided by 6 is equal to 10. Next, let's find the slope for freedom. Picking 2 points on the freedom line. And labeling my x1, y1 and my x2, y2. The slope for freedom is equal to y2 minus y1 over x2 minus x1. 120 subtract 80 divided by 10 subtract 5, which is equal to 40 over 5, which can be reduced to a whole number. And finally, Fido. Picking 2 points and labeling my x1, y1 and my x2, y2. The slope for Fido is equal to y2 minus y1 divided by x2 minus x1, which is equal to 60 subtract 50 divided by 4 minus 2, which is equal to 10 over 2, which can be reduced to a whole number, 5. Interpret the slope as a rate of change. Which plan is the cheapest? Well, why don't we write all 3 of our slopes that we found in part A into rate of change form. So Bell, the slope is 10. So using the units from my graph here, so amount of gigabyte data usage and cost. So the units are gigabytes and cost. So 10 is my slope, and now I'm just going to include both units to it, and now it's a unit rate. Freedom charges $8 per gigabyte of data, and Fido charges $5 per gigabyte of data. So which one is the cheapest? Looking at these unit rates, well, it's cheaper to go with Fido. There are some homework questions on rate of change in the workbook for you to try before moving on to first differences. First differences are the differences between consecutive y values in the table of values and that have evenly spaced x values. To find first differences, we must subtract consecutive y values. If the first differences are constant, you know that this is a linear relation. If the first differences are not constant, then you know that this is not a linear relation. Here we have two table of values, and the question is asking us to determine whether these relations are linear or nonlinear. At this point in the course, with what we've learned, we only know if these two table of values reflect data for either a linear or nonlinear relation if we took these points and plotted them on a graph and saw if it was a straight line or not. There is another way of determining whether our table of values is displaying information for a linear or a nonlinear relation, and that's with first differences. First, we need to take a look at the x column. Are your x values increasing or decreasing at a constant, or are they evenly spaced? In this example, yes, they seem to be increasing by 1. If your x values are not evenly spaced, then the work that we're going to do on the y values won't work out. So now we're going to look at just the y values. And what we're going to do is we're going to subtract them from each other. Hence the word differences. Differences in math means subtraction. We're going to start at the bottom. Our very bottom value for y is 27. And what we're going to do is we're going to subtract it from the y value just above it. And then we're going to do the same. We're going to start at 21 and subtract it from the y value right above it. Then we're going to continue. We're going to take 15 and subtract it from the y value right above it. One more time. And I encourage you to start at the bottom and not at the top, just to minimize any sort of error that could happen. Now let's look at our first differences, subtracting our y values. They're all equal to 6, which means that if we plotted all these points on a graph, this would be a linear relation. Since first differences are constant, which means the same, therefore the relation is linear. Let's practice again in B. First, we got to check our x values. Are they evenly spaced? Yes, they're all evenly spaced, all increasing by 1. So now we can perform first differences on the y values. 20 subtract 8. 8 subtract 0. 0 subtract -4, which is equal to 0 plus 4, which is equal to 4. And -4 subtract -6, which is equal to -4 plus 6, which is equal to 2. So now let's look at all of our first differences. They are not constant. So since first differences are not constant, therefore, if you graphed this relation, it would not be linear. Example 2. The school council at your school is planning to change the seating arrangements in your cafeteria. The different possible table arrangements are in Part C. Help the student council determine how many chairs they need for each arrangement. So here are the different table arrangements. Here's our table of values with just another column with pictures of each arrangement included. We can actually just rewrite all this information in a table of values that's easier to read up here. So I'm taking my X values and I'm placing them in the X column up here. And same with my Y values. I'm just going to place them in the Y column up here. Now I'm trying to find this right here. So when you have 4 tables, how many chairs is it? Well, let's find first differences. So first I'm going to just make sure that my X values are increasing at a constant, that they're evenly spaced, and they are. So then I'm going to find the first differences of my Y values. And I find that my first differences are constant. So this is a linear relationship. And I'm going to write that in Part B. C. How many chairs would you need if there were 4 tables? Well, we can answer this in many different ways. First, we can just draw it out. And so why don't we do that first? I'm going to divide this into 4 tables. And looking at the pictures above, it looks like there are 2 chairs on one side of one table and 2 chairs on the other, and then 1 chair on each end. So 2 chairs on every side of each table, and then 1 chair on each end. So that would be 2, 4, 6, 8, 10, 12, 14, 16, 18 chairs. So 4 tables is 18 chairs. So I concluded that by drawing, but I can also conclude it by using our change in X and Y values. Let's start with our X values. Our X values are increasing by 1 each time, reading down the column. Now let's look at our Y values. Reading down the column, they're increasing by 4 each time. So I could have also predicted that the number of chairs for 4 tables was going to be 18 by just reading the table of values and looking at the change in Y and change in X values. So as you add 1 more table, you have to add 4 chairs. You add 1 table, you add 4 chairs. That is the relationship between X and Y in this example. Last page. Examine the pattern below. Make a table of values comparing the term number and the total number of squares. So here's our table of values. So remember, your left column is your X and your right column is your Y. So the term number is down here. Term 1, term 2, term 3, term 4. So my term number, I'm just going to write 1, 2, 3, 4, and I'm going to continue all the way to the end of my table of values. Number of squares per term. So in term 1, we have 1 square. In term 2, we have 4 squares. In term 3, we have 7 squares. And in term 4, we have 10 squares. Before we complete the rest of this table, let's answer B. Is our table of values representing a linear relationship? Well, let's find the first differences. First, I'm going to ensure that my x values are evenly spaced, which they are. They're increasing by a constant. So now I can continue with finding first differences. And my first differences are constant. Since my first differences are constant, therefore, this is a linear relation. Now in C, it's asking us to complete the table of values and determine the 7th term in the pattern. So I'm going to look at how my x's and y's are changing. So we see that my x's are increasing by 1. So every time my x increases by 1, my y values are increasing by 3. So x increases by 1, y increases by 3. X increases by 1, y increases by 3. X increases by 1, y increases by 3. So 10 plus 3 is 13. X increases by 1, y increases by 3. X increases by 1, y increases by 3. So at term 7, there would be 19 squares. And the relationship between x and y is as x increases by 1, y increases by 3. Last question. Predict whether each equation is a linear or nonlinear relation. Just by looking at an equation, we can determine whether, if we graph this would be a straight line or not. And that has to do with the degree of the polynomial. A straight line, a linear relation, has an equation form, has a degree of 1 on the x. We're looking for x variables with an exponent 1. And I've told you in the past that when you have an exponent 1, you just won't write it. So you're either looking for exponent 1 or no exponent at all, which would then tell us that that equation represents a linear relation. The equation in A is linear because of the exponent 1 that's invisible, but it's still an exponent 1 on x. So we know that equation A is linear. B, the highest exponent is 2. So we would say that this equation has a degree of 2. So because the highest exponent is not 1, we know that this is nonlinear. See, the highest exponent here is 1. Therefore, we know that this is linear. And finally, the highest exponent in D is 3. Because it's greater than 1, we know that when graphed, this would not be linear. There are some homework questions for you to complete in the workbook to consolidate your learning of first differences. Great job today.